We're going to talk about electrons, electron shells, and valence electrons are going to be the main things we're going to talk about on this slide. We're going to draw some pictures. We're going to draw some little diagrams called a Bohr model. Let's go ahead and get started. So we've got, it's going to be about electrons. I'll erase those stray marks in a minute. So electrons are negatively charged and found in the electron cloud. Another thing is that they change the reactivity of an atom. They change so they change the reactivity of an atom, and what that means is that they, we'll talk about it more in a second, but when they are, depending on how many valence electrons there are, it changes how they interact with other atoms, so how reactive they are to connecting with other atoms similar to themselves or different from themselves. So I'm going to switch up color just to try to make it more visually appealing. And over here we're going to do electron shells. All right. We use circles to show the number of electrons. Kind of crypt on there. So we use circles to show the number of electrons, and this will make sense in a second when we start drawing. And when drawing these, when drawing this type of model, we don't draw each proton and neutron. So here's an example. Let's draw hydrogen. Again, I'm going to change the color just to be more visually appealing. Hydrogen. That's the first thing on the first element on the periodic table. And it has one proton. But we're going to draw it the same as if we draw any other atom or element, and so we're just going to have a nucleus in the middle, and whether there's one proton in there or 100 protons in there, we're going to draw it the same because we're focusing just on how many electrons there are. And if you want to change these to a different color, then you can. If you want to draw the electron a different color, or if you want to draw the nucleus where the proton and the neutron is, if you want to draw it a different color, then that's fine. That may help you when we're counting them. But hydrogen only has one electron. Let's change the color again. Let's draw helium, which is the next one on the periodic table. And again, we're going to draw the nucleus. Even though there's two protons here, we're still going to draw the one nucleus. And we're going to draw one electron up here and one electron down there. So unless we're told that it is an ion, it has a positive or a negative charge. We'll talk about ions and anions, but unless we're told that it has a positive or a negative charge, we're just assuming that it has a neutral charge, which means however many protons it has that same number of electrons. So helium has 2. We're going to write a number 2 here. And then the next one is lithium. We're going to again draw the nucleus, draw one electron shell, and then another. And on this one, something different is going to happen. Kind of run into a problem we'll discuss in just a second, but lithium can only, each electron, the inner circle, the first inner shell, can only hold 2 electrons. So once it's full of those 2, the electrons now have to start occupying another space outside, and that's the second one. So we're going to show this. The first circle has 2, the next one has 1. And we know that there's 3 electrons here. The reason we drew 3 electrons there is because lithium has 3 protons, and this is a neutrally charged, or it doesn't have a charge, and so it's going to be 3 electrons to balance out the 3 protons that are in that nucleus. All right, down here, some kind of rules that may help. Rules for Bohr's model. Okay, I'm going to say first shell, second shell, and third shell. These little quotation marks just mean that it's the same thing as above. So it's first shell, second shell, and third shell. The first shell can hold up to 2 electrons. The second shell can hold up to 8 electrons. And the third shell can hold up to 8 electrons. So in this second shell, in order to fill up this inner shell and start filling up this shell, this one has to be full of 2. So that's why we've got the 2 electrons. Well, once that first shell is done, if this next shell has 8 all over it, if it has 8 more, then that's going to be 2 plus 8, which is going to be 10. So for the outer circle, the outer shell, to be full, it needs 10 electrons. Using this, we're going to be going off the octet rule. So the outer shell is going to be 2 plus 8 plus another 8, which is 18. So we're going to draw a little divider here, just to kind of separate these 2 sections. And then I want to switch colors again. I'm going to draw a couple examples. So we've got 4 examples. We're going to go, I think that's misspelled, F-L-U-O-R, I think. I'm going off memory here. Fluorine and chlorine. So fluorine and chlorine, if you look at the periodic table, they're going to be right above each other, one or right above or below each other. So we're going to draw this. We're going to draw the nucleus, and then we're going to draw a shell. And this one's going to have 2 shells. I already know ahead of time this one's going to have 2 shells. So fluorine, its atomic number is 9. So because it has 9 protons, I know that it's also going to have 9 electrons because it's a balanced atom. So this first shell is going to be full of 2. And then because that's all it can hold, the next shell is going to have to start being filled up. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. We're almost full. There could have been 1 more that fit right there, but it's not going to because fluorine only has 9. So we have 2 in our first area. Do this in black. Has 2 in our first shell and 7 in our second shell. And chlorine is going to be something similar, except, well, let's jump over to neon. Neon's going to be somewhat similar. It's going to have the nucleus just like all of them, and even though neon is going to have a lot more in the nucleus than, say, hydrogen that we already drew, we're just going to draw the nucleus as 1 because we're not focusing on the number of protons and neutrons right now. We've got 1 energy shield, or one energy shell, and a second energy shell. So because this one's going to be neon. Neon has an atomic number of 10. So we're going to have 10 total. I know we're going to have 10 total. So we got 2, 3, 4, 5, 6, 7, 8, 9, 10. And if you'll notice, there's 2 on the inside, and then their outer shell, which we're going to call valence. It's these valence electrons. These outer shell, it's all full. So we're going to have a 2 and 8, and this is just showing whoever's looking at it, whether it's you or me or somebody else, it's showing that it's got 2 in the inner shell is full, and then that next shell is full. Let's go back to chlorine. We're going to go to yellow. Chlorine is going to be similar to fluorine. On this one, we're going to draw 3 shells. It'd be great if your lines lined up real nice on the computer here. I can't seem to draw really good circles on here. So, chlorine. So if you look at the periodic table, chlorine has 17 protons. So we're going to, we know that the numbers need to add up. These numbers that are going to go right here need to add up to 17. Let's go ahead and try filling them. So we got 1, 2, that's the first shell, 3, 4, 5, 6, 7, 8, 9, 10. So that's 8 on that second one. It's 10 altogether. So altogether that's 10. So if we're going for 17, then we know this one should have 7, is what we would expect it to have. And in fact, chlorine does have 7 on its outer shell. If we were to count those, it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. We've got 17 electrons. Almost. If we had this one more right there, then it would be, that outer one would be full, but it's not, so it's just 7. So 8 plus 2, or 2 plus 8 plus 7 is 17. Okay, let's do one that's similar on the, it's right beside chlorine on the periodic table, is argon. Draw a nucleus. 1, 2, 3. So the same thing. We know that argon is there's going to be a total of 18 electrons because there's 18 protons in this normal charge, a neutral charge. 1, 2, 1. So we draw 2 there. 1, 2, 3, 4, 5, 6, 7, 8. And then this is 10, so we can tell between 18 minus 10, there's going to be 8 on this outer one as well. So for argon has all 3, so 1, 2, 3, it has all 3 rings filled up. So let's take some notes over here on the side and explain what we just talked about. So these valence electrons. So this outer shell is known as these are known as valence electrons. Excuse me. When this shell is full, the atom is happy. I'm going to put that in quotation marks, happy, and doesn't react to other atoms very much. So because these valence electrons, the atoms on the periodic table, if you were to look at a periodic table, the atoms on the periodic table, the ones that we just did, were these four. So fluorine and neon seem like they're very similar because they're right beside each other. It would be because of how their electrons are set up, how their what they have in their outer ring out here. Because of what they have in their outer ring, they both have almost a full energy shell, electron shell. Because of that, they are very similar with each other, more so than fluorine is similar to neon. So you would think maybe fluorine and neon are similar, but they're not. This whole group, this whole column is called a family. And similar to most families, the characteristics within that family are similar. So maybe your family likes a certain football team, or they do a certain activity often, or they have a certain physical trait or attitude or something like that. The family similar in the same way. This family in the periodic table, each of these columns are similar. So chlorine and fluorine are more similar than fluorine and neon, or fluorine and oxygen, because of how many valence electrons they have. Let's go back. So because of how many valence electrons they have, and that valence, it doesn't matter how many's in the inner circle, because the inner circle is going to be the same. If it's full, it's the same. They have two. We're looking at the differences between all of these, from fluorine to neon, or from chlorine to argon, is how many. This one is missing one down here, so is this. But neon and argon, all of their energy levels are full. And that's why we kind of describe them as being happy. In the periodic table, we'll talk about this later, but this whole column, this whole family, is known as noble gases, and they don't really care to interact. They don't interact very much with all of these. And a lot of these want to group together to kind of act similar, to have a similar valence electrons as this group. So these are noble gases. They're gases at room temperature, and they are noble. I'd like to think of it as if they're kind of posh or snooty or bougie, and they don't like dealing with peasants, which are kind of the other elements or the atoms. So, for example, in nature, chlorine and sodium, they respond well to each other. They like connecting together, because chlorine is almost to the noble gases. It has one more electron. If it could just get one more electron, it would be happy, as I was saying. And sodium, it has one valence electron, and so all it needs to do is get rid of one. So this one needs to get rid of one, and this one needs to gain one. So if sodium and chlorine get together, they make sodium, they make salt. So we'll talk about that when we talk about in future lessons, but that's what we're looking at. So again, chlorine has three, if you look back at what you wrote, it has three energy shells, or electron shells. So we can see that 1, 2, 3. It's in the third row, and it has almost a full shell. That's valence electrons. It just needs one more. So you can tell that by, there's 1, 2, 3, 4, 5, 6, 7, 8. So it has 7. If you'll notice those numbers, its chlorine's numbers are 2, 8, and 7, because it has a full inner ring. Its second ring is full, and its third ring is almost full. Argon has 2, 8, 8. See, its last number is 8. So as you learn to do it kind of longhand, where we're drawing it out, it makes it a lot easier when you realize that there are some patterns that the periodic table helps us with.